Okay, so hello everybody. We are starting the first talk in the technology mix session, when I will present a successful transformation to the serverless architecture and mindset. And yes, I deliberately said mindset because I believe that, and I will try to show this in the presentation, that the biggest challenge regarding serverless adoption is in our attitude when it comes to the software development lifecycle processes. Um, who am I to talk about this? My name is Wojtek, and you can find me on the internet under the nickname Afronsky or AWS Maniac. The latter is my blog and the YouTube channel when I share my thoughts, opinions, and knowledge about AWS. I'm also a co-founder and cloud architect at Pattern Match, where we specialize in AWS and introducing serverless architecture with project ranging from classic web applications to cloud data platforms. Um, my passion and active interests are related with serverless data analytics and cloud databases. One thing worth mentioning to my Polish folks is that are listening, hopefully, is that I'm a translator of the Polish version of Running Serverless book written by Gojko Adzic. So if you would like to get a 10% discount from the ebook, wait at the end of the talk. I will have the information how to get the voucher. So enough of this shameless plug, let the story begin. The whole idea for the talk is related with the close cooperation with one of our clients. And it started as the usual way when it comes to the IT consulting slash advisory projects. We received a very interesting inquiry. This inquiry can be summarized in one sentence like, I cannot evolve, scale, and maintain our monolithic architecture. And all those informations that we receive during the process sounds great because it is a proper motivation for ditching a monolithic architecture. Sometimes you can see this motivation to ditch the monolith because uh, it's not modern enough, microservices are everywhere, and so on and so on. That's not a great motivation. From the other hand, if you see that client has the problems with evolution of the software development, that's probably a well motivated path to going out from the monolithic architecture. So we started our work, and but first things first, we scheduled a reconnaissance, our typical AWS account review. Then we scheduled an initial meeting with that client. And last but not least, we also scheduled a kickoff workshop when we will start the whole initiative and describe initial approach to the problem. And a review of the account revealed a typical syndrome of the unfinished cloud migration. At the beginning, there is an euphoria, everyone are excited, we are moving to the cloud, yay, and so on. We are building momentum, everyone are excited, as I said, and it stops. Why? Most likely because we didn't change our behaviors, utilization patterns, and so on and so on. As an effect, we are using cloud provider in this example, like on the slide AWS, like hosting, spending circa 8 grand per month in US dollars, mostly on IaaS and supporting services. Um, and it is also a common problem related with the multi-cloud setups. It sounds so great on the paper, like the cloud migration. In practice, those two projects are hard to execute, and they are tricky when it comes to the all intrinsic details. And especially in the part related to multi-cloud, if you would like to extract a common denominator, which is effectively like using virtual machines, some kind of burst storage, and virtualized cloud networking layer, that's not the way you can benefit the cloud because you are stripping off all the benefits and other services that are related with it. And it's like tipping a toe in the ocean and claiming you are swimming. And that analogy, this perfectly describes what do you do if you are stripping off all those great services from the cloud portfolio. On the other hand, embracing that portfolio requires deliberate effort, resources, and courage to deep dive. So that's the other side of the coin. Uh, and then we did the initial discovery meeting when we have revealed another problem, much more severe than just the cost ineffectiveness. It's not only about monolithic architecture, but monolithic infrastructure too. There was one beefy EC2 instance that holds one beefy SQL server with multiple databases. There are multiple Windows services running on that machine, which are sharing the same huge monolithic code base and doing so much. And I would like to step back here a little. It is really easy to judge and throw statements like, yeah, this is an ugly monster, and so on and so on. First things first, that's rude. Don't do that. It's someone's brainchild, so how dare you? And secondly, it's earning money and it's already providing a revenue to the company in opposition to you, ugly consultant. So uh, pay attention to your words. And there are already a hidden challenges in that scenario already, because some of you probably are having the chilly effect, and you are seeing um, the database migration lurking around the corner. And definitely that's not something that we want to touch right now. Additional problem is that they are using database like a queue, and has severe problems, like starting with the regular heavy purges that affects everybody else using that database, scalability and table sizes issues, ending with the rigidity and the architectural issues like coupling through database. Again, it's really easy to judge and saying, yeah, that's a bad pattern, you should change that, but it works and earns money. A right question to ask is how to replace that structure efficiently without tearing down everything and rebuilding from scratch. And being completely serious, what we can really do here, microservices are not helping here at all. And I will explain you why. We need to react much smarter. Those two problems are severe and they are hurting the company at the moment. We don't have time for a few years to learn operational knowledge, spending time on designing a complete replacement for this monolith in the microservices architecture. From the other hand, you can use such tools like Kubernetes maybe and so on. Really, is that really an option? First and most importantly, there are no containers there. Plain VMs, Windows services, almost no operational development knowledge about Docker inside the company. About Docker, not even a Kubernetes, which is another beast in its own. Secondly, such tool will not solve the problem of monolithic application anyway, because you will need to design it properly from the start in order to leverage such tools. So we don't have a huge amount of options here, but we can identify some quick wins if we will do and direct another approach to that problem. That's why we proposed alternative. Instead of eating an elephant for a year or two, we have time boxed our efforts and gave ourselves 6 months to deliver a valuable business solution. I know it sounds counterintuitive, but adding more constraint to the problem allows you to solve that problem more efficiently. You need to prioritize what's best. Especially time box is a very useful constraint. And remember, there is this Parkinson law, which is lurking in the dark, which states that any kind of work tends to expand to fill the time available for its completion. And if you will have those constraints in mind, you will prioritize what's best and attack problems in the right order, and also move some irrelevant issues from the scope of the original project. Then we have applied the most powerful tool from the software architecture toolbox, which is the composition. In this way, we have identified architecture seams, so places when we can inject our own new code, new components, and then we have listed the most painful points, which were mostly related to data index, scalability, integration to a queue inside the database, and so on and so on. And for all those pain points, we have identified places when we can actually react, introduce new components, and slowly, gradually rebuild the whole infrastructure and architecture, and also split the monolith properly. And where is the database migration project here? In our opinion, it was not feasible to do it in a 6 months time frame, as it heavily tangles other multiple subsystems and various components inside. However, bear with me, because as a side effect of this split, we have returned to that topic, and at the end I will show you how actually we achieved the very interesting side effect that we didn't expect, but we were able to leverage that. So let's talk about the scope of the 6 months pilot project. Let's talk about the services. First things first, we have identified that we can use some fully managed services available in AWS to replace the current approach to manage stuff that they are doing on their own. First example is Amazon S3 and Amazon SQS for queuing and saving those incoming transactions instead of building the queue inside the database. Um, Using fully managed services has a very great side effect that we can leverage additional features, and those features are also fully managed to actually reduce some operations that are done via code or via other services that we have to maintain. Great example is to you leverage the S3 lifecycle process to do periodical purges instead of doing the purges inside the database, which inside the database and this table that handles the queue. So having those features, additional features inside the fully managed service helps us to offload the work and actually reduce the operational complexity, but also reduce the amount of code that is necessary to implement that solution. Another quick win related with fully managed services, if you have too many files to operate on S3, you want to investigate them, annotate them properly, and so on and so on, do not worry. You can do those operations over the uh, tens of thousands of files on S3 via services like S3 inventory and S3 batch operations. If you want to search through those transactions, you can use Amazon Athena, and it helps tremendously with troubleshooting, debugging, and stuff like that. So introducing one additional service opened us into using other fully managed services in a proper way to actually deliver value and not introduce additional operational complexity. Um, when it comes to the processing pipeline, it was essentially a way of leveraging Amazon SQS, so managed queue for incoming events, and two services, one for stateful processing, AWS Fargate, which is based on the Docker containers, but doesn't have the whole overhead of managing your own Kubernetes clusters, and AWS Lambda for stateless processors in a event-driven architecture manner. Everything is event-driven architecture here, but AWS Lambda has a specific workflow inside that helps you to handle the stateless processing logic. And when it comes to troubleshooting, we actually implemented the uh, DLQs with the use of Amazon SQS, which allows us to have both reprocessing and troubleshooting in place. Additionally, when it comes to stateful processing, we introduced additional small database with help of Amazon DynamoDB for caching and initial configuration. And thanks for that, we actually can implement a stateful processors inside the same architecture that we share with AWS Lambda. On the level of the code base, we implemented our applications to have the core of the logic very cloud unaware. And then we just implemented skeletons, templates, as we called them, for the applications, just for using inside the Fargate and just using inside the Lambda. And thanks for that, we can actually have a reusable logic for consumption for AWS Fargate and for AWS Lambda. And core business logic is implemented in a way that you don't have to be bothered by problems like integrating with the particular cloud provider and so on and so on. We essentially leverage the hexagonal architecture there in order to have ports and adapters to switch between different services inside one cloud provider. And last but not least, we still have this legacy database that we planned to not touch. So how to avoid to hammer down this thing? We actually leverage another set of services, basically the same services that we used SQS and AWS Lambda or AWS Fargate, to have a concurrency controlled writer and have a steady stream of updates that will not overwhelm the database at the end. So we basically implemented this with the help of the serverless architecture again, in order to, let's call it a downscaling the whole scalability thing. As I said, the biggest problem of that approach was not related with the scalability. It was more related with the ability to evolve and deploy frequently and avoid the monolithic architecture in that sense. So we decided to actually skip the database migration and leave it for further phases and focus on the development first and development experience first. We have identified some additional wins too, and some of them are related to additional tools. For example, we have identified that we can use the AWS serverless application model instead of the pure AWS cloud formation to ease out the first experience with infrastructure as code. And that was actually a great choice because the team that was responsible for that migration, they actually do not have a lot of experience with AWS, very little actually, and they do not want to learn about intrinsic details and quirks related with the cloud formation because they have a lot of other tasks to do instead. So we actually leverage additional tools to ease out this first experience with infrastructure as code on AWS, and that helped tremendously. Additionally, we've got a lot of luck because for those of you who work with AWS and .NET Core, you know that AWS is not the fastest provider when it comes to embracing newest version of .NET Core. And we've got huge luck that support for .NET Core 3.1 arrived just in time, especially in AWS Lambda. So our migration from 2.0 to 3.1 was seamless and instantaneous. Guys handled this perfectly. And additionally, we've got very good decision about choosing proper cutoff points, and that helped us tremendously. One example is the database that I mentioned already. And as I mentioned, scalability was not a problem. So we decided to actually have the cutoff point in this place and introduced additional temporary elements to do not involve in the painful migration in the first place. Additional thing was related with the entry point for that application. On the diagram, there was an application load balancer, but the truth is we didn't start it in that way because we, at the beginning, we need to have the same entry point for the whole system. So that was not a problem because we just introduced feature flags in that monolith and split our path into new one and the old one. And we were able to reroute some traffic to the system with the ability to preserve the same entry point. This constraint about the entry point was related with the with requirements regarding the network security because we still have to use the same whitelisted IPs. We are having a lot of edge locations, and those edge locations have the restricted network environment. So we had to preserve the same IPs in order to have the same path and do not introduce additional whitelisted services and so on and so on. So for those of you who work with cloud, you know how inappropriate is to expose your own IPs. So instead, we actually leverage the old path, prepare the proper solution in parallel, and implemented the feature flags in order to speed up the development process and do not wait for the full implementation. However, not all was bread and butter in that case. The truth is that we had very little technical issues on the path. There are two traps in Amazon S3 for that particular use case. First one is related with S3 event notifications and the situation that we snarkily called probably wants delivery, because in the documentation there are explicitly stated informations that they are not guarantees any time delivery. There is no guarantee for order delivery of those events. So if you would like to leverage this mechanism that somebody uploads the object into a bucket and you will receive an event to your AWS Lambda, you will not have the guarantees you will expect to have in the first place. So we have to ditch this idea and re-implement it a little bit differently. And there are some obscene costs when it comes to the put and get operations for many small files on S3. We actually overcome that issue. So first things first, we implemented that in a classic way without bothering about the costs, because our gradual rollouts was not pumping up this particular cost factor. But eventually we replaced that issue, we replaced that situation with a different service, managed service called Kinesis Data Firehose, when we actually leveraged batching and allowed us to save a lot of money when it comes to that particular element. Additionally, we've got some small issues with the .NET Core integration with AWS SDKs like AWS X-Ray and tracking the operations across Lambdas and SQSs, but that was fairly easy to solve. Also, we have some challenges, technical challenges with local development and debugging. To put it in other way, I think that there is totally different set of problems lurking in the darkness. And being completely honest, when I summarize technical issues and issues with peopleware, amount of issues on the peopleware side was overwhelming. So let's tackle those challenges one by one. First things first, this problem with the local development was partially technical, but it required change in the mindset as well, because people need to understand how to use those services locally, how to mock them properly, how to leverage test environments, and so on, which is not a particular way of working for that team. So we needed to overcome those issues first. Also, oh, sorry. Yeah, back onto track. So speaking about the other stuff, we also observed that introducing a lot of new elements like event-driven architecture and stuff like that required a lot of adjustments, and learning curve was a little bit steep for some team members. So we need to investigate what are the options and what are the paths to learn this efficiently, and also to build the internal knowledge bottom up in order to percolate the information about the architecture, to spread around the knowledge, how to use Lambdas properly, how to implement that logic, and so on and so on. Learning about AWS and how to operate with AWS. This requires additional adjustments and effort from our side. However, operational change was much harder for us. This situation has this contextual thing that we have teams that were responsible solely for the development in the past, and the operational team that handles the deployments and operations. And we wanted to change that, or at least adjust that situation. And a great example about the friction was how much and how hard team fought for the access to the production AWS account to help operational teams with troubleshooting. And again, it's very easy to judge, but the truth is that both teams need to have acquire the trust and build up that trust in the process in order to accommodate that change, because this change will not happen overnight. Yet at the end, people proved their engagement and got that access to the production accounts, and that they are helping on a daily basis with the troubleshooting as a third tier of the support. But that required a lot of the mindset change on the operational side and building that trust. Another point related with Terraform and AWS CloudFormation, AWS SAM, sounds like a technical issue, but it's not really. It's basically a situation with old versus new thing. As we introduced AWS SAM, we had arguments why, and also first things first, we need to support our need for introducing additional operational tool. And after winning that argument, we had to backport some of the scripts to Terraform in order to bring the familiarity to the operational guys, in order to have both unification and similarity when it comes to the tools that they are using. And again, it was not related with a technical challenge, more like with basically a distinction between those two teams and different tools that they are using. And last but not least, we have a constant fight with priorities between old and the new platform. You need to be prepared that the old priorities will try to preempt our people involved in the new project. And we were actually fully aware of that. That's understandable. The truth is that we need to have a plan to deal with and how to bounce back those requests. Because if you are rewriting the application, you will eventually have uh, those kind of issues with the priorities racing and so on and so on. So at the moment, the team has a full product ownership, delivers regularly, like they are doing deployments very frequently, 2, 3 times per week. They onboarding new processors, re-implement the monolithic architecture into the smaller set of services. Those data producers are being sliced into the smaller pieces. And we are actually introducing a lot of new improvements to the whole platform. So you may say that my job as a consultant is done and we are living in a fairy tale when they live happily ever after. That's partially because this project is actually very successful, and boom, we obtained another opportunity because COVID-19 strikes back. Um, I know I understand that the reality is that COVID-19 hit many businesses tremendously, and many of those businesses suffered. But this particular client received a very unique business opportunity because of that situation related with pandemic. And that was the case with the second project. This time it was a greenfield, a new team inside the same organization with no AWS experience at all. And they have 3 weeks to deliver an MVP. And the truth is that they have 4 weeks, but they spent 1 week evaluating, can they do this in their current architecture that they plan to do? The truth is that they were not able to implement that particular thing in their architecture. And my role was to convince them and to re-architect the whole solution with the use of the serverless architecture. Again, with the help of the decomposition and identifying the very narrow scope and taking a huge technical depth, obviously, we have identified a critical path and successfully delivered this project on time. It turned, it turned out again that the technical challenges were not an issue. We observed another problems on the peopleware side and the same problems that we observed in the first project. Um, what was that project? It was basically a real-time video processing engine that evaluated each frame based on the previously trained machine learning model. And this whole solution should scale to handle hundreds of video streams. Luckily, we had a working and trained model already. So this thing shouldn't be possible in 3 weeks if we will don't have that model, obviously. So luckily, we do have this model. But our architecture was also fully serverless, and we invest a lot of time to narrow down the scope in the thinnest possible application, in the thinnest possible MVP. We've managed to do that, but there are some caveats on the way, technical too. First things first, we've got small fights with the Amazon SageMaker, which is the AWS service for machine learning and hosting models and so on and so on. There are some REST API limits. There is this thing with model conversion. Marketing and documentation says that it should be seamless. The truth is that we spent a day and a half to work with it in order to have the full support. There are some hidden data transfer costs, but eventually after a day and a half, we overcome all those issues and then part with the model worked flawlessly. There are some other issues with services that are deliberately not serverless or even driven friendly. For example, Kines video streams does not have any integration with AWS Lambda. And if you would like to leverage AWS Fargate for that, you are required to write custom logic and scaling for that consumer logic. So you need to re-implement that from scratch. And we also spent like a week and a half solely on implementing that layer in order to have it scalable and to be able to consume the video streams. Of course, you can use the integration, the official integration with Amazon Recognition Video, but if you don't know the service, many of you that probably heard about it, you know what is the issue. Um, this service is absolutely expensive and does not allow you to host your own custom models, which was the case for us. So this integration is basically out of scope for us since the day zero. And we also discovered in anger some cost effectiveness issues with the Amazon CloudWatch, but we actually overcome that at the end. Technical issues were not a problem. Um, at the end, we achieved the whole solution, which was cost efficient, that provided revenue. Uh, it is scalable since day one because at the day one, we onboarded 50 video streams, and on a daily basis, we onboarded additional video streams. Eventually we hit the limit because of the technical debt that we created, but in the meantime we already re-architected and reapproached the solution, and um, at the moment the whole solution is scalable and it's fully serverless. Again, in my opinion, main challenges were related with peopleware and convincing people that they were able to deliver and smash that accidental complexity that is visible on the surface. And to be fully honest, I totally understand that, because from the perspective of a person that does not know AWS and does not know serverless, all those colorful diagrams are just noise because they don't understand what benefit brings the particular service. And also those services, to use it effectively, they require operational knowledge and experience gained in the past in order to avoid pitfalls, because there's plenty of them. So in my opinion, the whole point of building confidence is the most important thing to embrace the serverless architecture, because on the surface, those diagrams and those architectures looks much more complicated than our familiar monolith or other familiar architecture that we designed, because we have this strange um, feeling that even that we designed much more complicated thing and we need to take care every single detail, we have the full control over that, which is, in my opinion, illusion, because clearly, if you would like to design a very complex system, you need to start from a simple one in the first place and then evolve to a complicated system. You won't be able to build a complicated systems from scratch, because clearly you will miss something, you will forget about the edge cases, and so on and so on. So it is a time for a short recap. First, let's talk what we can do better. Are we serverless enough in both projects? Of course not. In the first project, we can go deeper, definitely. We already using more serverless solutions, in this case, Kinesis Data Firehose that I mentioned, and we can implement additional improvements over the architecture in order to have the fully serverless approach. Why I focus on the serverless approach here? Because we gained very unique elements like lower operational complexity, lower operational overhead, ability to involve team in the product ownership. All those elements are very important from the software development lifecycle process point of view, and we would like to leverage that in the future as well. So definitely we can bring more and more serverless services to the picture, and serverless and fully managed services to the picture, in order to build that cloud native culture. And also we can do a predictable and planned monolithic database split. That's a must. But in order to do that, we need to identify another set of quick wins, like we discovered by accident that during the re-implementation of the logic, we have untangled a first piece that can be migrated during the first phase of the monolithic split. And we are already starting the effort regarding the migration with the AWS database migration service. So thanks to the whole effort related with re-architecting and serverless architecture and building that from monolith, we actually discovered that we can do a very short and painless migration when it comes to the part of the database architecture from the scratch. So what serverless gave to us for free? Basically, it allowed us to build cloud native culture in anger. And it resulted in a much better product ownership, and operational effort is much smaller. The learning curve is less steeper. People are less afraid to be involved because even from the high level, if we will see those colorful diagrams, there's a lot of components. The truth is that there is not so many moving pieces involved, and people are actually over time feeling more familiar and more confident to operate with those services. And at the end, they are responsible for maintenance and introducing features, deployments, and so on and so on. I am really proud of that team regarding the product ownership, because having that, we already won in a tremendous way. We are building product ownership since day one, and I am really proud that team fought over the access for the production account. I'm really proud that how diligently they took care about the cost since day one. They have implemented calculators in the spreadsheets. They evaluated every single service in a proper way to discover the cost efficiency and problems with cost efficiency for those services. So this product ownership and building that internally for those teams uh, provided us with a huge amount of insight, and we already built those teams and prepared them for future to leverage even more from the cloud. And scalability and availability was built into the solution since day zero. Uh, Thanks to the fully managed services, we were able to achieve both scalability and availability with the lowest possible maintenance costs. And last but not least, we've got very fast development and evolution. I think that delivering the whole project in 3 weeks proved to the team and to the organization that they are able to deliver some stuff much quicker, and they are able to leverage that architecture and that style in the future as well. So I would like to emphasize on three things here. First things first, challenge with serverless is not technical in my opinion. It requires people and culture shift, and I will give you an example. We have introduced cloud native services, AWS as a cloud, new programming paradigm, which is event driven, and architectural style, which is hexagonal architecture, ports and adapters. We have introduced Docker, and people smashed all those things without any issues. Not to mention that they already moved from .NET Framework to .NET Core on the fly. So people actually smashed those technical issues without any problems. The biggest challenge was to change their approach and to software development process, and to help them overcome the complexity at the beginning, to convince them that they will manage to do that. So everything is related with this accidental complexity that goes and surfaces from the diagrams, and to build the confidence that they will able to manage and fully utilize those services, those fully managed services. If you will build that confidence, and if you will build this culture of ownership, um, you already won, and the technical issues are irrelevant. Um, Secondly, you can be really fast when it comes to software development thanks to serverless services. Uh, there's one caveat. You need to know what you are doing. As I said earlier, if you don't know exactly those services, if you didn't have the operational knowledge, experience gained in the past, you may drown in the accidental complexity of the cloud services portfolio and all those pitfalls that are waiting for you. I know that on the marketing sides, it looks perfect, it looks brilliant when it comes to the features and how easy it is and so on and so on. The truth is that you need to know what you are doing. Obviously, it is very simple and much simpler than maintaining and building such solutions on your own, but you need to be aware of those deficiencies. And third, assuming that you know what you are doing and your team is capable of the technical delivery, I think that there is a shortcut from monolith to serverless, and you don't have to invest time in the microservice architecture, at least at the beginning. And don't get me wrong, I don't say that I'm not saying here that microservices are irrelevant or you will escape it. Eventually, you will face all those issues with serverless and microservice architectures because they are having the common denominator. Those are distributed systems by nature. Issues will surface. However, operational complexity is much lower and it's much easier to attack in the quest of the delivering value in a pragmatic way. In other words, serverless architecture allows you to postpone some of those operational challenges, and eventually you will face them because, as I said, we are operating in the distributed systems environment. But still, if you will think about it, for the teams that are learning that in the process in anger, that is a huge win to have such opportunity. And that's all what I prepared for today. Thank you for the presence and attention. And if there are any questions, I will happily answer them now. On the slide, you can see a contact to me, and there's a link at the bottom about getting the voucher for running serverless Polish edition. Thank you so much for the attention, and I'm passing mic to the studio.